I found a few articles, I didn't post them yet, about algebraic, like matrix representations of graphs, but I don't know if that interests other people as much as it does me. And I'm still like, that's not it yet, because it's okay for graphs, but not for recursive hypergraphs, yada, 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 yada.
Yeah, we can talk about that. I had some, also like some years ago, some insight about the algebraic graph construction stuff.
Oh, that would be a great conversation. I had a totally different insight today. I was hoping to wait for Stephen, but since he's not there, or yesterday, yeah, I'll get started if you're okay with that. Or
I'll just have to say that at 7 o'clock I'll have to go.
Good.
So I'm limited to 7 o'clock.
I'm happy with time casting. Okay, what's everybody's idea of an agenda? I've had one insight I want to get into, but we said we'd talk about algebraic logic representation of claims.
Yeah.
Yes, that and probably the parameterized claims thing.
Yeah, and I prepared something. I've heard your last talk, and I prepared something. It will take me about 5 to 10 minutes to show it. It is the answer to your discussion last time.
Okay.
That would be great. Yeah.
Sounds great. So I'll go over my things quickly because it is pretty quick, and I think it's important. We've often had a conversation about scoring. Like, do we do truth? Oh, Stephen might join. Let's see. I'll wait for him if he's about to. Okay. Guess what I was listening to? He was there Monday, though. On my way. Okay. No, I want him to be there.
We could also just start with Tal's presentation because it's recorded anyways. Ah, there he is. Okay.
Hey.
Hi, Steven.
Totally overlooked. I thought it was 1 hour later because the time zones changed, but then they must have changed on your side as well or something. Either way.
They changed a while ago for us.
Mm.
Okay, so we have a lot of people with things to say. I'll try to go quickly. I think, Stephen, you've argued for the feasibility logic, Dong's work, right? Before?
I don't know whether I argued for it or mentioned it.
Yes.
But yeah, I definitely read up on that and I cited in my paper, yeah. But
yeah.
What do you mean by argue for?
I don't think that's that important. You mentioned it, fair enough. I'm beginning to have more and more of an insight that, you keep saying the whole point of having a lot of the things we do are for the sake of scoring. And I'm saying it's not necessarily scoring. It may be kind of a link of the feasibility links. And I'm realizing more and more the feasibility score, it can be a very simple logic where you say, basically, here's a claim. It's maybe just mentioned, right? Is that true? So it may be a question, maybe posited. It may be asserted, contested, and or opposed, I should say. And then these claims that assert or oppose it, that support or oppose it, and again, we've decided that there's supposed to be absolute versus supposed to be weak support, like strong or weak support. We've made that distinction. Those claims themselves may be supported or opposed, and so on. And I was not that keen on the feasibility logic, but I realized it does actually make a lot of sense to have that in the data model. It's not scoring, but it's about, is a claim supported, opposed, or controversial? It's not true, false. It's supported, opposed, strongly, weakly, or controversial, meaning there's both support and oppose. weak or strong, it doesn't matter as much. Though I guess there is the interesting case when there's weak support, strong oppose, or vice versa. And basically a controversial claim would not act as support oppose. It would be blocked from. So you can have a cascade mechanism. And the reason I thought about that is that I've been talking a lot about event sourcing, and I realize it's the same mechanism. I was thinking about keeping track of the time any claim was in the data structure, because then I will know, oh, it's been contradicted later. And that's a way of doing removals. But I realize actually, if I keep it, or not in the cache, but keep it in the full data structure, and then I have the contradiction. If I want to reassert it, I'm basically contradicting its suppression, including the link of support. So it solves the CRDP problem without keeping the event structure. I can just contradict the contradiction to reassert the claim. Well, I'd reassert and contradict the contradiction. And that makes it order independent and monotonic. So I'm realizing that the logic that is useful at the event resolution data level is also useful as a simple way to, as a simple truth model without scoring.
Yeah, I'm not certain I can follow.
Yeah, sorry, I'm speaking.
Can you, so I understand that maybe that you make the connection to event sourcing, but I don't think it's relevant to try to explain what you mean, right?
No,
can you maybe focus more on
that was a bit of an aside, yes. Let's focus on the claim structure. So a claim is posited. It may be affirmed or denied independently, right? Without giving reasons, I'm saying this is true, this is false, or just saying, oh, I want to think about this. What do you think, folks? And then people will come up with support or oppose arguments, which have their own.
It's recursive.
Yeah, which have their own underlying premises, which are claims. And these claims may have support, and you can also support the argument itself. Is that a valid argument, and so on. So that's recursive, as we've always done. But what I'm saying is, from there, we can compute a kind of complex truth value, which is not based on scoring, which is about saying, is this claim mostly supported, mostly opposed, or is it controversial? That is, there's both support and oppose. And we can even introduce a distinction between, strong and weak opposition, which we've expressed as a Boolean, the proves Boolean.
Yeah, so my opinion on that has always been, I don't want to do that. Whenever I say I'm not interested in scoring truth, that's what I mean. I don't mind calculating metrics to show, like the two metrics that I always highlight that I want to calculate is the depth, like how much underlying arguments are there, more like, and the bias, like are there more arguments being made to say one thing than the other? That doesn't say much. What I mean by that, if you make one argument for one side and one argument for the other, does that mean that it's 50-50, or does it mean that what does it mean? In the case of Godebot, Bentley then assumes you don't know one way or the other. I don't want to make that conclusion. I just want to say, well, there's been argued equally much for as against. That's the metric that I think users can relate to and understand. That's the only thing. Like it's a metric of bias of discussion, if you will.
Well, see, you're looking mostly at the controversial claims to start with. I'm saying in the support, there's some claims which will be equally controversial, used to support something, but some that are uncontroversial. And I want to mark this claim is controversial, consensual, and in many cases, the opposing arguments will themselves be opposed. So I'm saying if we nullifying opposed argument, we can get a kind of metric. Is there solid opposition? Is there solid support?
Why do you need, so one thing I realized early on is whether or not something is controversial, you don't need recursive scoring. You only need one level of scoring, like how many people believe in the claim, how many people don't believe in it. You don't need recursive scoring for that, right?
No, you can get recursion if the only opposing claim is itself opposed and not supported. Then it doesn't count. Then there's no controversy on the claim.
But define controversy. Like for me, the easiest way to measure controversy, if people individually can express belief in a claim or not, you have your metric of controversy. If you have 50 people believing in a claim, 50 people don't believing in the claim, you know that it's controversial
I'm not even counting belief or disbelief. I'm just saying, is there an argument for believing or disbelieving that? Is there? Or is there a uncontested argument for believing or disbelieving that?
Okay, but then you're not really trying to score controversy. You're trying to score the truth score that I think Bentley is also trying to do. You're trying to have some type of metric that, like, based on the argument structure, how much reason is there to believe that this is true or not? And that's what I keep saying. I don't even want to pursue that, because
fair enough, you don't have to. But I'm saying I wouldn't call that scoring, much less than what you say about how many people believe or disbelieve.
I think we've been ambiguously calling all of these scoring right now, so it depends.
You have it. I don't. Okay, we have different. I agree to disagree on the definition of the word.
I think
scoring.
I always call it like that because that's what it is called in the white paper, in Timothy's white paper. Yeah, Timothy.
One point real quick. I think you're wrong, or you misunderstood or something. Bentley's reason score. It's not just like how many on each side. There's weighting as well, which means that arguments can be weighted as better or more important than others. So it's not just a count on each side. But I think maybe we should table this discussion because it's an ongoing discussion. And let's focus on Tal because he's here for us today.
Yes, I agree.
Okay, cool. Can you? It's been recorded. Okay, cool. So I've listened to your discussion, and I hope that I understand it well, and I'll try to respond in a philosophical way. And so, sorry. Okay. So let me share the screen. I prepared a paper. I can send it. It's just abbreviations of everything. So, do you see my screen here?
Yes.
Yeah. Okay. So from what I've listened, I understand two things. Claims have truth value. It's not true value, and it's true or not, and maybe it have uncertainty. Right, Mark? I understand that this is what you've said.
Yeah, that's part of the. It can have, yes, definitely.
Okay.
By the way, Marc-Antoine, if you don't mind, or Mark Anthony, that's fine, but Mark is not me.
Sorry, Mark Anthony. Okay. I hope I'll send you a link so you can correct me later on. Okay, and another thing that I've heard from Timothy is a claim with the embedded formula shouldn't exist. A claim is the output of a formula. Okay, we have enough force to go to space. This is a sentence that you used. And I want to relate to those things. So I hope I can find a solution. Okay, so first of all, I want to talk about, if you have questions, please do, okay? So first of all, I want to talk about truthiness, okay? For instance, this apple, okay? If you see an apple, you say, okay, I see an apple, it's a valid claim, it has a truth value, okay? I believe it's true that this is an apple. But this is something very simple. We all see apples, and we can agree if we'll be in the same room and say, okay, there is an apple on the table. But on this theory, which I hope you probably know, which is the flat Earth. So everybody in this room, I think, was not an astronaut, and all the Earths that we can see are pretty flat. So why is it that we believe that the Earth is round? And we have used a lot of logic to understand why it's round and not as our eye look at it, why it's not flat. Okay, so This is much more controversial, and I believe most of the people, I'm not sure in 2021, but in the 20th century, most of the people agree that this is a false claim and the Earth is round. So we have trouble to understand what is truthiness, or how to understand if it's true or not. Okay, because none of us seen. Maybe if you'll be astronaut, we'll see. And this problem of knowing thing is also related to art. So this is not a pipe. The famous image, picture. Okay, so
Magritte, yes.
yeah. So there is an issue, and I'll try to relate to that of what is truthiness, and also I'll talk about claims and functions later on, and try to show a model that can explain where there are functions inside claims. So first of all, I want to suggest another epistemic system, okay, a way to look at things, and I'll use Reichenbach and Kant as a source, okay, and I'm calling it the phenomenal cage. And this, what Kant says is, we don't have any, we cannot see it's called the phenomenon, okay, we cannot see the thing in itself, we cannot see this dove, we only see the reflection on our eyes or on what the brain interprets. Okay, so we can never get into the real world, and therefore we are always blocked inside this cage. We cannot go outside, so we can never know if it's true or false. Maybe it's the brain vet thought experiment. Maybe we just are connected to a computer. So in this case, we say we don't have true and false. Okay, we can never see if this is an apple. Okay, although we can all see it on the table, you cannot say it's true that this is an apple. This is something that you have to get out of the system. There is no true or false. Don't be shocked. I'll find a solution for that later on. Okay, so I'm not looking for solipsism or something like that. I'll just show you how we can solve that. So, so we can never know that a claim is true or false. So can we use beliefs? Okay, I believe this is an apple. I believe this is a dove. And this is, I think, that if we'll take about beliefs, so we are going into solipsism. Okay, I have one set of beliefs, you have another set of beliefs, and we cannot relate to each other because we don't have a way to bridge between them. So I also don't use beliefs. What I'll use is, in a minute, I'll show you how to solve this problem. There were many attempts to go outside the phenomenal cage. I think most of them failed, or all of them failed, by philosophers over the time. I don't know of one philosopher that was able to get outside the cage. So I'm suggesting something which comes from Ernest Mach, and Occam Razor, as you know. We just have to assume that the thing in itself, the nomenon, is simple. It's just for convenience, and I'll show you why. Okay, so we assume we don't know that it's simple, and probably it's not simple. But there are two main reasons for that. First of all, it's easy to remember. Okay, when you have theory, it is much easier to remember a simple theory than a complex theory. And another thing is, it is easier to test. Okay, so if we take those dots, we can say there is a simple theory that connect them, and there are infinite other numbers of theories that connect them. And we'll take the simplest one, not because it's true, it's just because we can test. We can say, okay, let's search here and see if there is another dot here. So if the theory is true or not true, or we'll talk about another thing, we'll find it here. So to solve things, I say let's assume simplicity. Let's assume the thing in itself has very simple laws, and all we have to do is this is coming from Karl Popper. we only have to guess, which is, we call it conjecture and refutation. It's not falsify, but refutation. Okay, so you can try and refute and try to build a theory. And basically what we was talking about was, let's see if I'm not running too fast, but it's talking about a falsification of theory. This is the falsification criterion, okay, that we have to test theories and they should be falsified. And what we have instead of belief is corroboration. Okay, we can corroborate a theory. It was tested many, many times by me, by you, by everybody in this room, and we think this is highly corroborated. Okay, and by the way, for a theory to be negated or to be falsified, we only have to have one observation that contradicts it. So if I've heard before by Steve, it's you have to just have one contradiction, basically, theoretically, one contradiction, and the whole theory will fall apart. In true life, it will not go like that because usually you have to check if the contradiction was real, was it tested correctly, etc., etc. So basically, in order to and when a theory is falsified, what you have to do is to create a more complex theory which will explain all the observation, and I say all the observation you've seen so far. In real life, it's very hard to go to that, so we'll use other means. So basically, and here I'll tell you, in science, you have measure for that, and stop me if you don't understand or if you don't agree, okay? But I'm running.
I'm doing a running commentary in the chat. You may be missing it.
Okay, so I would prefer doing it in the document. So let me send it to you on this paper. Okay, so copy a link, right? So can comment, copy a link, chat, send you. Okay. So you have in real life, when you are not in a scientific laboratory or doing statistical experiments, you have feelings, you have levels of corroboration. You have a feeling that it's right. You have hypothesis, which is which is a theory that you devise based on some previous theories. You have theory, you have practicality. Say, yeah, this is an apple. We all know that this is an apple. Or you have technology, because we know that smartphone works. So the theory behind smartphone is highly corroborated. And you have level corroboration by the member of the community. So basically, and this is go for Timothy, I'd say that for each statement, you have two things. One is the level of corroboration. Not all statements are corroborated at the same level. And also you have a probability, which means that if I say I don't know, let's take something very simple. The next one will be 100% white. And you'll see, and you say, because all swans that we've seen so far are white. So you have probability. Or maybe cats are brown and black and white. Okay, the probability of having a cat with only brown is 1%. So, and together I call it a chances. Okay, we have chances that this thing will success. That the next thing that we'll see will have a chance to be true on the observation. It's not true that the observation will be correct based on those two parameters, probability and corroboration.
Question.
Yeah.
Are you talking about prediction here?
Yeah, of course. Every theory, every claim is a prediction that says that something about the world, and we hope to see in the next time that we're going to see it work according to this theory.
Okay, yeah, got it.
Okay. So what I say, for instance, and now I'm going to say about the claim also. So this is about compound claims that you've talked about. Okay, so to understand what is a statement, I'll say that a statement usually will describe an object or objects with their properties, or several objects and their properties. For instance, we'll go for, I'll use the Socrates is a man, all men are mortal, therefore Socrates is mortal, the famous syllogism. Okay, and let's say Socrates is an object. It has properties. Properties are something that is they are stationary, let's say, or something like that. And you have unique property and general property, and you have method, something that the object can do. And we are all coming from scientific, from computer science, so we know what is property and method, right? I'm not. Those are all things that you know.
Yes.
Okay, and you have unique properties, something only by the object, and you have general properties, which is, we'll see in a later. Properties is a reference to other objects. So for instance, if I'll take this statement and just to explain, and we'll go back to what you've talked about, Timothy, is that Socrates has the property of being a man. Okay, and we will say that its corroboration level is, we believe that it's 100% that it's corroborated, it's highly corroborated that Socrates was not a robot, okay, or alien. There may be other, by the way, when you aggregate, there will be other people who say, no, Socrates was an alien, okay, he wasn't a man. Okay, and humans have other properties, okay, and men and humans have other, for instance, mortality, and we say corroborated one, I'm going from 0 to 1, 100%. And so we can say Socrates is a man, all men are mortal, therefore Socrates is mortal. So we know this, that mortality is a property of Socrates. And of course you have also, if you want to say, okay, he's a male, and we can say what was his color, because we know, because he was a male, and if we get it, we'll put an input into the age, stress level he had, let's say what were the Greece blondes or darker hair, and we can say what was the color of his hair in relation to his age. Okay, also we have corroboration and probability. Okay, so we know that in his 50s, only 1% are having black hair. So those are numbers inside. Those are, if I'll go back to what you've said, we have here the function. Okay, so we can say Socrates' hair at the age of 50 was probably white. Okay, so here we have a function. This is a function basically, and here it's not a function, I'll call it a property. And for all of them, we have corroboration and probability for each of them. Okay, etc., etc., etc. And if you talk about compound claims, so we'll say that A result B, result C. So we'll say that, and I'll call this, again, this is, I'm looking about the chances that it will be true in the next observation. So we'll say that the chances of A results B results C, so it will say, it will go for the chance, the total chance will be A chances, multiple B chances, and C chances. So this is the compound theory.
Sorry, A results B, that means A causes B and B causes C? This is not a compound claim, is
okay, it? Maybe I didn't. For instance, let's say, give me a compound claim.
Well, the Socrates is a good example in the sense that there's two premises to the conclusion, right? It's Socrates is mortal is the conclusion of the two independent claims. Socrates is a man, all men are mortal. So there's no causality between Socrates is a man and all men are mortal, right? There's
I'm not talking about causality, I'm talking about relation.
Okay, I'm trying to understand what you say by result here, because I don't get it.
So
I think putting this into terms, not necessarily causality. What he's saying is that it has been established. Well, yeah, it has been established through a similar process or whatever, a claim process, right? That all humans are mortal. In other words, is a corroboration between, or correlation between humans and mortal is 100%, right?
Yeah.
And then because of that, when you make a claim, Socrates is a man, if that is 100% true,
Yeah.
it automatically follows that Socrates is human, and therefore Socrates is mortal, because the corroborations are all 100%, as opposed to there being wiggle room in there.
That's not related to my question.
Yeah.
I don't understand the word results. Is it associative? Is it causal? Is it epistemic? What does it mean?
No, I think it's not causative.
It means you do the math and get.
It just there is a relation between A and B and C. Okay, a relation. It's not result. I think better. There is a relation between in the case of Socrates.
Calculates too, right?
Well,
calculates
example,
to what we've seen last time.
Yeah.
So
but because the way it's written, it sounds like there's a relation between A and B, and there's a relation between B and C. So these are two independent claims. So it's not a compound claim. What I was mostly opposing to is this does not look like a compound claim to me. So maybe there's a algebraic interpretation of connection that makes it a compound claim, which I don't see. Even if you say that, that's still not a compound claim. These are two independent claims. A is connected to B and B is connected to C.
Do we have a good example of a compound claim?
I gave the Socrates example. I think it's a compound claim. Two premises, one conclusion. The conclusion does not.
No, but what he's saying is A therefore B therefore C, right?
Yeah,
in that case, it's a therefore, but only because it's 100% corroboration, right? When there's 100%, it's A therefore B therefore C, right? If it were,
there's a difference between, there's parenthesis missing. Is A therefore B, comma, B therefore C versus A therefore B, parenthesis, therefore C. Those are different statements.
I'm not
okay. I get that point.
It's not. It's about therefore. Okay, there are a lot of connections. Okay, so I'm thinking there. If you go into this logic structure, and you said there is a connection, and again, the connection between Socrates and man is 100% corroborated, and human and mortal 100% corroborated. Therefore, Socrates is immortal 100% corroborated. This is what I'm saying. And there are many way of connections between all those properties and methods.
Okay, so basically this is not a mathematical formula until the total. Unconnected B, connected C, I should not see it as meaningful. Sorry, I'm being.
So maybe you'll suggest something else, but what I'm saying that there should be a logical connection. Okay.
Yeah, I'm saying C is connected to A and B. A and B together are connected to C.
Well, we can write it. For me, just now is just that it will be understood. Okay, maybe you can suggest something else, and I'll go with that. Yeah. I'll do just another step and say that I created a data schema. Let's show it in here. Okay, what I suggest is basically that, for instance, Socrates is an instance of human, but I'll write it here. So the type is human, probability 1, corroboration 1, and here I'll define human. Okay, this is what I'll call a referenced property. Okay, so we human are mortals, etc., etc., and also they can walk. By the way, I can relate humans to mammals. Mammals can walk, or etc., etc. And again, everything has probability and corroboration, and they can. It's not inheritance, but it's a reference property. Okay, so I'll just go until the data schema, which I suggest.
This is very close to frames, right? As proposed by Minsky. Frames.
I don't know the issue.
In the, I wouldn't say early, but fairly early days of artificial intelligence, Marvin Minsky proposed Society of Mind. He proposed basically he called them frames. They were kind of schemas saying if you have this type, you have these slots, some of which have values that are defined by virtue of the type, some of them which have to be defined by virtue of the type, but depends on the individual, maybe with probabilistic measures. This sounds a lot like frames. And a lot like if you look at Leonard Psych, for example, he was using frames a lot. So this is familiar. And that's not wrong. I mean, frames, I believe a lot in frames. There's this whole system called FrameNet that is being developed at Stanford that uses frames mostly on actions, not on less on entities, but it's still the same principles. You say what are the arguments, the slots of different actions in this case. But it's also true of entities. Like if you have an entity, you have certain properties that are virtues of the frame. And in a way, I mean, as you said, O learned a lot from frames.
Yeah. By the way, I'm a biologist. By my first education was biology, and I'm taking it mainly from how the brain is working. And when I was a student in my MA, I developed an AI engine, and it was something like that, and it worked. But it wasn't my main concern, so I dropped it aside and continued. And when I talk today with AI experts, they've taken another way to solve, and I think this one will make a much better machine brain, because it's know how to understand the world much better than what we have now. But
it's again, frames are a good way to enter knowledge. I'm just saying there's a lot of precedent.
Yeah,
I'm
so
surprised.
I'll be ready to read about it.
Yeah. It's definitely not wrong. And it's related, as you say, to the study of typicality in the human brain, which again is certainly useful. That my main problem with a lot of that research, personally, my criticism is that it uses English words as placeholders for concepts. And that means that they come with all the baggage of ambiguity that natural language comes with. And yes, you can make it more precise, but I'm saying there is work to be done to make it more precise.
Yeah.
Of course, the other thing is that many things belong to many categories, which may or may not be impossible in your system. I'm just saying people who do hierarchical ontologies, single inheritance ontologies, I think are really missing something essential. Things belong in many frames. And then what happens when the frames agree or disagree? But usually that's less of a problem than.
Yeah, I do try to solve it. I'm not saying that I've solved everything, but
no. But the notion that belonging to a frame gives you a lot of context, right? We speak a lot about implicit premises in our conversations. And it's a fact that many implicit premises are actually given by the frame.
Yeah.
Like once you've said this belongs in that frame, and that's why for me distinction is so important, because distinction is about saying this name is ambiguous, and that means that the entity referred to by the name can fit in many distinct frames. And so it's interesting to know which are the distinguishing characteristics between the different frames that an ambiguous name can belong to.
I'm sure there is a lot of research. What I'm trying to do in this thing right now is to try to understand, did it answer in some way to what Timothy said and what you've said? And so I know that Timothy has an issue with formula and sentence, etc., etc. And does it solve something for you and Timothy?
For me, it actually goes into a different way of looking at it, which is interesting. and it gets to sort of what Marc-Antoine was talking about, probabilities and predictions and so on. What it doesn't solve is the fundamental. Well, it begs one question, or it opens the door to one question, which is, where do you get those numbers for probability and corroboration?
Oh,
Each one of those attributes is a
Debatable
claim.
yeah.
Each one is a claim that the probability is something, or that the corroboration is something. So that then in itself is, and then how do you pull in that number?
How do you model the argument about that number?
Yeah.
Right.
So
the thing that is the thing that we were getting at, that I was discussing about, like a compound claim is not a claim, is because if a compound claim is a formula, in this case, you've stated the formula implicitly, which is essentially A of whatever is A of X times B of X times C of X, or that is a formula, right? And what I'm saying is, given of C, given a value for each of those,
yes,
there's no debate about the result of the product, right? You're not going to sit there and debate, no, 5 times 4 times 3 is 59, it's not 60. You can debate the result we're looking for is 59, and therefore there's something wrong with your formula or your inputs. But we're not going to sit there and debate 5 times 4 times 3 is anything but 60. Right.
Yeah, and basically we said, there's 2 stages that way. There's the uncontrovertible result, and immediately after that, there's the debatable claim.
So I want to answer one at a time. For you ask, for instance, where do I get those numbers? And in the theory that I'm developing, and I think there is what we call mental object network, MON I call it, and there is social object network, and those numbers basically are individuals. So it says that you believe that Socrates was a man, and you say I believe the probability that he's a man is 100% and the corroboration is 100%. Maybe I can say another thing and say no, he was so smart, and it was happening so far ago, it must be an alien. Okay, so I'll say the corroboration is 0. Maybe I'll give it a 0. So this is in the individual level. Everyone gives its own corroboration level. Okay, I do believe, I don't believe, I slightly believe. And well, I use again day-to-day words, but it's corroboration. And as a society or as a group, we may have a assimilation of all the corroboration, and we can say this is highly controversial, this is not controversial. Okay, because we can say all the members in this group are divided on the level of corroboration that Socrates was human. So this is for your, this is where you get the numbers.
This is the one half of the answer to the solipsism issue, right? As I said, one reason solipsism is you cannot prove it false, but it's extremely boring because you cannot prove it. You cannot prove anything. It's not generative. It doesn't help you predict what's happening next. So once you've decided out of solipsism for that reason, because it's not intellectually productive, then you start thinking, what's the escape from it? And the escape for it is social verification. And that's why echo chambers are a failure of collective cognition, because then you get biased, self-assortive social corroboration. There is in practice the fact that the numbers are extremely hard to know. Like I probably have in my wetware neural network a corroboration for certain things that has a number that could be measured if we knew the neural network, but we don't. So we have proxy measures, and psychologists have gotten pretty good at transforming a huge battery of questions and answers into an approximation of a probabilistic measure, but it's a lot of work for every single individual measure. and going for how do we know how we adjust this individual measure when confronted with obviously different measures from people around us, depending on the relationship we have with those people. That is an unsolved problem in psychology, though we know that there is an influence and we know it's not linear. Like there are cases where being put in a social context where people disagree with you will make you double down on your inconsistent belief, and others where you will follow the group. So it's not a simple relationship.
Yeah, but
that we know.
So first of all, I do have in the lib is my software, the software that I'm producing. I do address that, and I just give it a range bar. Say, how do you believe? How much do you believe in this thing? And this solve it for me. And I agree with what you said about the problem of society, okay, or echo chamber or group polarization. And we have to try to solve it by trying to, for instance, how to call it, to re-engage the group with people that don't think alike, to create
Yes.
a heterogeneous group. So this is, we have to change the settings so we'll have not homogenic group, but this is not in the number. The number is basically, for me, is just a range that I'm taking from one side to another. For me, it's enough for my case. Maybe one day I'll have a, and we can connect to the brain and.
Okay, let's say that there's been psychological studies and the issues with self-reporting, but maybe it's adequate for your use case. Fair enough.
10 minutes left, by the way.
Yeah,
could we go back to compound claims?
Yeah, sorry.
No, but it's the question of, it is a question I'm asking myself. How much can we quantify this? We can do all kinds of measures, and I certainly intend to do it as well, don't get me wrong, but I'm also acutely aware of the limits of quantification. And that's why I'm looking at what are the more qualitative relationships between claims in terms of saying this is held to be a more basic truth than that. Like it's easier for me to doubt this than to doubt that. I think this is how I'm trying to think about this, because I think it's easier to answer those questions that, how strongly do you believe this? And people are notoriously bad about self-reporting on probability or belief. But is this belief based on those, on this evidence? And if this were proven wrong, would you modify that belief? Now that's getting more interesting. The relationships are key.
By the way, what I suggest is, I know I agree with all what you said, and I say, for instance, people have skewed perception of the world. So one of the things to do, and I think this is related to your work or to the whole group work, is to say, okay, science found it to be probability of 20%. Okay, but you can believe in whatever you say, but this is the scientific measure. You can trust it, you cannot trust it. But you have, it was tested rigorously and got 20% probability.
Plus or minus something.
So any other question, or you want to go to another subject?
Let's go back to compound claims. Oh, go ahead, Tim.
Well, yeah. Part of and maybe we should try compound claims because we have such short time. The one thing I was going to say is, each person choosing their number for corroboration, for example, or for probability, doesn't open room for debate about that value. And people trying to prove that value just kind of ends the debate there, and you make up your mind about that. I guess what's missing from the picture is, where do those arguments and relationships fit into those numbers?
So it's very, for me, it's very easy. You have a claim and everybody can show otherwise. Okay, I claim something, you can show otherwise. And by the way, usually it will break. If you have a valid contradiction, it should break all the theory. The other one that suggests the theory should create a better one. So you can falsify a claim.
By the way, I like the emphasis on corroboration. Let me ask you, how do you represent an argument in this system? Basically, you've shown us modelization of entities, and the claims are kind of embedded in the entities. But how do you model arguments, like the relationship between two claims?
This is something I'm working on for 18 years.
Okay.
But if you challenge me, I can try to have a solution for next time. Or if it's too much for you, give me 1 month and I'll try to give you a solution for that. But I'm feeling that I'm near it and I can close it and I can show you how objects are related with this data model.
Okay, and you've seen what we've been doing on modeling argument. Do you find faults with it, or do you need to, or have you seen it in depth? Because there's been so many. I can't believe you have seen all our. There's too many.
I need a summary. I need a
You
summary.
need a summary. Fair enough.
Yeah.
Summary. Fair enough. Well, basically, it's very simple. The argument itself is a claim. We're having some, it has multiple premise, and there's some argument between us between, does it intrinsically have multiple premise or does it have a compound premise or both? I'm now personally going towards both, but we agree that there's multiple premises one way or another. Mm-hmm. And there's a conclusion, which is usually a single simple claim. So if all those premises are true, then we will consider this conclusion to be either proven or supported, because there's arguments has a strength, it's a absolute proof or a corroboration, as you'd put it. Yeah. We have not yet agreed to put a number to that corroboration, just not proven. That's what I meant by strong or weak. So it's that simple at this point, but it's a claim itself. That means it can itself be contested. It can itself be subject to another claim, to another argument, and so on and so forth. So it's a recursive structure that way.
Did you write a paper for that, or
can you show the diagram quickly, Marc-Antoine?
Yes, absolutely. No, we don't. We haven't written a paper.
Something that I can relate to.
Yeah, no, we should definitely.
Until you find, I'll just tell you that I started working on the lib number 4 with scientists from Weizmann Institute and from Tel Aviv University. So, and we are going in the parallel way with you. So maybe.
Also, it would be very interesting to hear what you came up with, like what your insights were for this version 4.
Yeah.
Okay, so that's the So it's really quite simple at this point. We have the compound claim is made of other claims. So that's one model. We're trying many of them for size, so to speak, but that's one of them. So basically support our argument. It's got a premise and a conclusion. Here we have the idea that there's a single premise because we have the compound claim for multi-claim premise. And you'll notice we don't even have.
Do you have an example for that? So I don't understand what is disjunction and conjunction in this.
And an or, sorry. There's a way, we're saying most compound claims end up being in conjunctive normal form.
I can show some examples of the an and argument.
Please do.
Let's see.
If you have it around.
It'll take a second to load up, probably. Debate map's not totally.
So anyways, Tal, would you be interested to join further discussions with us?
Sorry?
Would you be interested to join further discussions with us to work on this?
Yes. I think you've gone very far from the last time I met you.
Yes. We're talking 3 times a week.
Wow, amazing.
Yep.
Yeah.
No, we're working hard on this.
So Timothy, can you show it?
Well, I'm trying to find the debate here in the. It's like all my work's gone. Where'd it go? Maybe it's in a private. It must be a private branch. Yeah, okay, there it is. How do I share? Where's the, there we go. I mean, this was something I was working up as different ways to model the same sort of discussion. And I was trying to pick a very complex situation. And the complicated situation here is trying to prove that one thing is more than the other. In this case, it's the COVID lockdown will save, like the value of life saved in the COVID lockdown is more than the cost to the economy, right?
Mm-hmm.
So there's multi-premise arguments in here.
Yeah.
In this case, it's pretty simple. It's bringing together two different things, which is, you know, a value placed on the life saved and a value placed on the damage to the economy, right? So there's a mathematical relation that is inherent here that isn't actually built into the system, and that's where we're talking about formulas. For one thing, it's like if your claim is that A is greater than B, then there's a concept of plugging in a value for A and plugging in a value for B. At the same time, you have to maintain the notion of non-mathematical arguments that can be applied at every level.
Okay.
So
I understand that. If you can send me, Mark and Anthony, please, can you send me that diagram? And Timothy, if you can send me this link. And I'll show you one thing before I really have to go. Let me share screen for a second, and I hope next time I can help with what you've just shown me, Timothy. So, okay. So tell me when I can share a screen.
I think you have to
go ahead. Oh, do I have to stop it?
Yeah, you have to stop it.
I'm not finding the button. There it is. It says pause share. Is that the same as stop now?
Yeah, I think so. Yeah.
You cannot restart while
there it goes.
Oh, yeah.
Okay, now you can go for it. Yeah.
Yes. So very shortly, and for next time, where are we? Yeah. So there is a, to answer that one, what I've talked just one now was a simple claim. We have a claim, and there is a calculation for that. When you have resources, and you have outcome, part of them are good, bad, and this is something we do profoundly is to compare them. How do you compare several paths to solve a problem? Okay, so we'll say we have, it takes a lot of resources to solve in that way, in this option, in that way, and there is other option which create those outcomes. And I have something that I created. I'll create it for next time. How we can relate those one to those one, and how to compare between the options. So I think it can help in your case, but I really like to see the issue that you created. Okay, so I can be more specific. I'm finishing. Okay.
Okay, I have a hard stop too now. I have to go to my meeting.
Yeah, I have to go. So guys, it was a pleasure.
Yeah, thank you very much for joining, everyone.
Welcome.
Bye.
Bye.
See you on Tuesday. Bye.